Hello, YouTube. This is Mr. Bakari, and today I'm going to give an introduction to solving trig equations. Okay? And by introduction, we're going to use the probably the easiest strategy, and that is the ones where all we need to do is isolate a single function and solve for x. Okay? So I do want to clarify first that secant x, secant theta, secant alpha, they all mean the same thing. Our unknown variable is an unknown angle. Okay, so we're solving for angles here. All right, let's get started. I first want to show a graphical representation of sine x equals 1/2. So here's a graph of sine. And if I draw a horizontal line through 1/2, horizontal line through 1/2, that is y equals 1/2, where that line intersects the graph of sine, those are my solutions. Now, the first thing we need to realize is that we are solving equations along a given interval. Okay, we're given a domain of which we're solving angles. Now you might be asked something like for all angles. So if this graph is infinite and we want all angles where sine is 1/2, we've got to know how to write that. So what we're going to do is we're going to look at the principal values, okay? And so what I mean by that is the principal values are along the interval of one period of our trig function. So one period of sine is 2 pi. So if I look from 0 to 2 pi, I can see I've got a solution at pi over 6 and 5 pi over 6. Okay, so that's my principal interval. So I'm going to write theta or x equals pi over 6 and theta or x equals 5 pi over 6. Now, if I'm asked for all angles, I basically have to go both directions infinitely. So to show that interval, I'm going to add a period of the function I'm working with here, which sine x is 2 pi. And I'm going to follow with the letter n. Okay? So what n means is any integer. So it could be positive or negative, which would account for negative angles and positive angles to infinity. So for all angles, that is my solution set. Okay? But more often, you are going to be asked for a specific interval, solutions along a specific interval. So for this example, the interval is negative 3 pi over 2 to negative pi over 2. Okay, all angles including negative 3 pi over 2 to negative pi over 2. So now I'm going to take my purple line y equals 1/2 and I'm going to extend it along this interval, negative 3 pi over 2 to negative pi over 2. And as you can see, I now only have one solution. Okay? So the number of solutions will change depending on the interval you are given. Okay? All right, so let's look at these and solve these algebraically. So the first thing we want to note is what is the interval we're solving on, and it says 0 to 2 pi. So we are solving for angles 0 through 2 pi, and we're looking at radians, okay? So again, we are solving trig equations today where the strategy is to isolate a single function and solve for x. So we want to isolate secant here, secant x. So I am going to move -9 over to the left. No, I'm not. I'm going to move -10 secant x to the right. Okay? So I'm going to add 10 secant x to the other side. That's going to cancel. Get a thinner pen here. 2 is what I'm left with equals 4. And then I've got a positive secant x. Okay? All right, now I'm going to subtract 4. So 2 minus 4 is -2. And now I've isolated my function. Okay? So now I want to look for angles where secant is -2. So where is secant negative? Which two quadrants is secant negative? Well, that would be quadrant 2 and quadrant 3. All right. And secant is r over x. So r has to be 2, where x would be -1. And so now I have enough information to find my reference angle here, which is going to be 60 degrees. So I'm looking for this angle and this angle down here. Of course, I am looking for radians. So that would be 2 pi over 3, 2 pi over 3, and 4 pi over 3, 4 pi over 3. And I'm done because I'm looking in one rotation, 0 to 2 pi. Those are my two angles where secant is -2. And it's as easy as that. Okay, let's look at another one. All right, here I'm going to move tangent over to the left. So I'm going to subtract 3 tangent x from 4 tangent x, which gives me tangent x minus 7 equals -6. Now I'm going to move the -7 over. Tangent x equals 1. Okay? So I've isolated tangent, and now I'm looking for angles where tangent is +1. So what quadrant is tangent positive? That would be 1. Everything is positive in quadrant 1, and tangent is positive in quadrant 3. Okay? Tangent is, of course, y over x. And so if my legs of my special right triangles are the same, then I've got a 45. Okay? Again, I'm looking at radians, but this time it's from 0 to pi. So that would be pi over 4, and this would be 5 pi over 4. Okay? Now we got to look at these. I'm looking on the interval of 0 to pi. Well, pi over 4, that is definitely between 0 and pi, but what about 5 pi over 4? That is a little bit more than pi, so we are not going to include that in our solution set. We only have one angle here, and that is pi over 4. Okay? Next problem. Okay, as you can see in our domain here, we are switching to degrees, and we start at a negative angle and we go to 270. So -90 to 270, including -90. And we are also seeing for the first time a squared trig function here. So keep this in mind. So the square applies to the output of the trig function, not the input. So we write that cosecant squared x. Okay? So that's something to keep in mind. So another strategy here, if you ever get confused with these, you can always replace your trig function with just simply an x. So if I call cosecant x, then this is my equation. And that might help you put things in perspective. Okay, now I can see this. This looks like a familiar algebra function. And it might help you figure out what to do. I need to subtract 7, divide by 3, and take the square root of both sides. Okay, so that's what we're going to do. All right, so I'm going to subtract 7 from 11. And then I'm going to divide by 3. So 4/3 equals cosecant squared x. So now that I've isolated cosecant, I'm going to take the square root of both sides. Okay? So you want to be careful when you do this because the square root here is just cosecant x. But if I'm taking the square root over here, I'm going to get plus or minus square root of 4 is 2, and I'll leave that square root of 3. Okay? So plus and minus. So now I'm looking for where cosecant is positive and negative. So if I were to draw this out, I always like to draw these out. I don't want to assume everybody memorizes all these on the unit circle. So I kind of draw it out just for a visual here. Cosecant is positive in 1 and 2, negative in 3 and 4. And we've got r over y. R over y. So we really just need to look at one of these because we have symmetry here. So our reference angles will be the same, and that is going to be a 60. So that is 60 degrees. All right. So let's look at all the angles all the way around, and we've got 60, we've got 120, okay, we've got 240, and we've got 300. Okay, 60, 120, 240, 300, one rotation. But we're looking from negative 90 to 270. Okay, so remember, cosecant period is 2 pi. So if we looked at adding 2 pi n, so that's adding a rotation, but if n is negative, that would be subtracting a rotation. If we added that to 60, and I'm sorry, we're looking at degrees here, so I'm not going to write 2 pi, I'm going to write 360, 360 degrees. If I subtract 360, I'm way past negative 90. And if I add 360 to 60, I'm past 270. So now I'm going to write my final solutions down here. 60, I can't add or subtract. Now I'm going to look at 120. Okay. And if I add or subtract 360 degrees, that takes me out of my interval as well. So I can't do anything there. 240 degrees fits into my interval. And if I subtract 360, is that going to put me past negative 90? So let's see. 240 minus 360 is negative 120. So that's more than negative 90. So then we're going to look at 300, and 300 we're going to omit because it's greater than 270. So these are all of the angles where cosecant is plus or minus 2 over root 3 between negative 90 degrees and 270 degrees. Okay? All right. We're going to look at two more. So on this one, we are going from negative pi to 3 pi, including negative pi. Got it? And now our strategy here, we're going to move sine to the left. So we're going to subtract sine, which gives us 4 sine x plus 2 equals 0. Subtract 2, 4 sine x equals negative 2. Divide by 4, sine x equals negative 1 half. Okay? Where is sine negative 1 half? So I'm going to come up here and I'm going to draw my triangles. Sine's negative in quadrant 4 as well as quadrant 3. Sine is, of course, y over r. So y is negative 1 when r is 2, and my reference angle is 30 degrees. Or in radians, that would be pi over 6. So that angle is 11 pi over 6. And this angle is 7 pi over 6. All right, so from negative pi to 3 pi. So what we really need to do is be careful here and look at 7 pi over 6. And what we want to do is add one period of sine in radians, 2 pi n, okay? So we got to go both directions because we're going from negative pi to 3 pi. Now I'm going to think of 2 pi n as 12 pi over 6n. Okay? I just wrote that equivalent as a 6, so now I have a common denominator. It's going to make things easy. So if I subtract 12 pi over 6 from 7 pi over 6, that's going to give me negative pi over 6. Okay, negative, sorry, negative 5 pi over 6. There we go. Okay, if I subtract 12 pi over 6 from 7 pi over 6, I get negative 5 pi over 6. All right, and if I subtract 12 pi over 6 again, that's going to take me past negative pi. So I can't do that. I've got 7 pi over 6 as a solution. Now, if I add 12 pi over 6 to 7 pi over 6, that's going to give me 19 pi over 6, which is a little bit more than 3 pi. So that's as far as I can go. All right. Now I'm going to look at 11 pi over 6 plus 12 pi over 6. And now if I subtract 12 pi over 6 from 11 pi over 6, that's going to give me negative 1 pi over 6, which is good. That is in my interval. Okay. And I'm going to include, of course, 11 pi over 6 because that is in my interval as well. And if I add 12 pi over 6 to 11 pi over 6, that takes me past 3 pi. So these are my 4 solutions. Okay. Now, what I want to do real quick is I want to show you a graphical representation of what we just did. So here is sine x equals negative 1/2. Again, you see my horizontal line at negative 1/2. And up above in yellow, I have drawn the interval of negative pi to 3 pi. What angles is sine negative 1/2 between negative pi and 3 pi? And as you can see, that is negative 5 pi over 6, negative pi over 6, 7 pi over 6, and 11 pi over 6, which is exactly what we got. So I like to look at multiple representations, especially when you're solving trig equations, to kind of make this concrete and show what it is that we are actually finding here. All right, so hopefully that kind of helps solidify that. All right, we're going to do one more here. And if you want to try this on your own, go ahead and pause the video, come back, and we will work it out. Note that we are looking at degrees, all angles between 0 and 300, including 0 to 300. Okay? All right, so I see that I have a cosine squared theta. So I am going to subtract 1, divide by 4, and now that I have isolated cosine, I am going to unsquare it. So I'm going to take the square root of both sides. All right. So the square root here is cosine theta. And the square root of 1/4 is plus or minus. Don't forget your plus or minus. The square root of 1 and the square root of 4. Nice. Plus or minus 1/2. So where is cosine positive and negative? Well, all quadrants. So I like to tell my students we're drawing the bow tie. Okay, that is an ugly bow tie, but we get the point here. All right, so I've got a triangle in each quadrant. Where is cosine plus or minus 1/2? Cosine is, of course, x over r. So my reference angle is 60. So there's 60. There's 120. And we've got 240 and 300. Is that right? Double check. Yep, we're good. Okay, so that is our answer. 60 degrees, 120 degrees, 240 degrees, and 300 degrees. If we were looking from 0 to 2 pi, but we're looking at 0 to 300. So this isn't 0 to 360, 0 to 300. Now, 300 is not included, so we have to get rid of that. Okay? 60, 120, 240 all fit within the interval. We're good. Those are our solutions, and we are done. All right. So I hope this was a good introduction to solving trig equations. Okay. There's going to be a couple more videos where we look at other strategies as we move forward through this unit. I hope to see you there. Have a good one.